Hello, everyone. My name is Kei Lee. I'm with UfiSpace here in San Jose, California. And I'd like to spend the next few minutes sharing with you the open network solution. So to start, I'd like to give a little bit background of our company. We've been around in the business for about 10 years. And during the last 5 years, we've been transitioning into the networking space and focusing in two different lines of business. The telco and also the mega scale data center. And what we are showing here is the footprint of where we are around the world. Mainly, this is a Taiwanese company headquartered in Taiwan. We have multiple development centers in Taipei and also Hsinchu. And then on top of that, we have a couple service centers in Southern California serving our Northern Cal customer. And then with Europe and also Japan, we are planning to open additional service center in those areas. And last but not the least, we partner with our contract manufacturing companies to build all our product in our Asian factory. So that kind of share a footprint with where we are around the world, covering the different theater and the different customer footprint and all that. The company is extremely engineering focused, with the majority of the people in our company are engineers, over 2/3 of them. And then we actually are focusing both the telco as well as the data center solution. So I'm going to give some examples like how we actually utilize this with our worldwide customer. So first, I'd like to explain a little bit about what is open networking. Traditionally, with the traditional network, the networking actually in a somewhat closed proprietary system, meaning the hardware, the software bundle, and usually you buy from a single vendor with all the information bundle in hardware, software, and also their maintenance contract. With this model, you are being controlled by like one single entity. So you really, as an end user, don't really have a lot of flexibility to move things around. So for example, you need a certain solution for your next data center or your next central office. In a traditional network, all the feature set will be bundled, regardless you need those particular feature set in the software, and you kind of have to go with the bundle solution. Versus in the open networking, you have the ability kind of like take it into different pieces and only pick and choose the one that is relevant into your environment. So those are the ability to give the end user the flexibility. And not to mention, this whole model is a lot more agile, giving you the flexibility, only pay as you go, only get the information or the feature set that you need. And eventually that contribute the bottom line, which is both the OpEx saving as well as the CapEx saving. So those are the two key elements why the industry is migrating from the traditional network into the open network. Is giving you the flexibility, the being agile, the pay as you go, and pick and choose the feature that is only relevant in your particular environment. All right, so here we are giving a quick comparison in the high-level architecture of what a traditional system versus a disaggregated open system. So on the left, we are showing a traditional chassis, and this chassis has been in the industry for decades. Everything is bundled functionally into one entire box. And then we look at the entire design in the open disaggregator model, and we break it down into the different functions. So like the control plane, and then the functional data plane, all the line card, all the different 100 gig, 400 gig port. We are building this thing into different pieces into a cluster on the right-hand side as it is shown. And the reason for breaking it down has one main reason, and that is to give the user the ability to do the pay-as-you-go model. So for example, you deploy a brand new data center, you estimate certain capacity from day one, But then as your business grow, you need to grow the size of the data center. You need additional port and all that. On the left-hand side with the traditional chassis, you have no choice but have to start with a pretty big chassis with maybe 1 or 2 single line card. On the open disaggregator model, on the right-hand side, you basically only purchase and provision the hardware. And for those capacity you need from day one, and you can expand the design without touching the existing installation. As you grow, you can keep adding additional device onto the cluster as your business grow, as you are adding more user, more resources, or more server farm, that kind of thing. So I guess you can see the flexibility of giving the user and eventually contribute to the cost saving. And not to mention this design also built in with really great redundancy of all the cross connect from the controller down to the fabric, down to the line card. So that's kind of the highlight on why the open solution on the disaggregator model actually makes a lot of sense in terms of the interconnectivity, the scalability, and also the scalability for both the hardware and the software. All right, so what we are showing here is a end-to-end typical design of a telco environment. So from the left all the way to the middle to the right, we are showing the left with all the different access, either connecting to a traditional cell tower or a home user via the broadband or things in the nature. And then moving a little bit into the right is this aggregation layer where we aggregate tens and thousands of home users, or maybe even at a higher number. And that goes into the aggregation layer. Then eventually it gets into the edge and the core. And that is part of a traditional MPLS network, the multi-protocol label switching with the provider edge. And then with the server farm, the data center shown on the right-hand side. So this is a very typical architecture in a large-scale telco environment or a large-scale network enterprise customer, how the end user going into the access all the way to the server farm resources on the right. So we play pretty much on every single layer, from the access to the aggregation in the middle, to the edge, eventually to the core, and then into the data center. Every line of business shown on this architecture that we actually provide solution along with our software partner to provide the different types of scenario. And later on during the presentation, I'm going to show you a couple use case, and you'll be able to kind of do a little bit of deep dive into how this thing actually play. And I do want to emphasize this whole thing is based on off-the-shelf merchant silicon. And so it makes the economy of scale to be a lot greater, and with eventually the money saving on the CapEx, and also because it's an open system for the lower the OpEx, and all these will contribute back to the end user. And that's why this model is being adapted widely by a lot of large customers that we are working with. All right, so going into a couple of the use case, I like to start with some real user testimony. This is actually from one of the large tier 1 carrier here in North America that we've been working with them for some time. So this picture is extremely similar to the architecture diagram I showed on the previous slide, where on the left we have all the access layer, either from a cell tower or from a traditional small office, home office, going through the metro Ethernet, then into the aggregation, into the edge, eventually into the core of the network, there where the end user will access all the server farm resources, things like that. So this has been implemented for some time, and we like to highlight some of the statistics on the right-hand side with this particular testimony from this large carrier here in the US. And over 50% of their production traffic are now running on this disaggregated model, and with tens and thousands of cell tower actually migrate to this open system. So all in all, we want to showcase this is actually real. It's not just a paper design. We do have production traffic running with some very large scale customer. And for those of you are interested to take a closer look the entire testimony, we provide the link on the bottom of this slide, and then you can take a look at the link with the entire write-up. And we just want to highlight some of the key points to showcase how this thing is actually in action. So moving forward, we like to share a couple more use case. With this use case here in North America, that we want to focus on the access. We are homing a very large number of cell tower traffic across North America into a regional hub or application layer, and then going through their MPLS backbone into their core. So this is one of the example using our cell site gateway, our S9500 model. This is based on the Broadcom merchant silicon with the Crumon AX chipset. And this is one of the example focusing on the access layer on the left. Then moving a little bit to the middle, and then this is another customer we are working with in South Asia. And now we are moving away from the access, and this is in the core. This customer is actually utilizing some of the core technology based on the Broadcom Jericho 2C plus family and building the core of their MPLS network, the P node, and also the provider edge. And this is another example in production that we are partnering with this customer in South Asia. And again, we are sharing some of the real life example around the world that large scale customer are adapting to this. And a few other examples we like to highlight is another North American large customer also building their backbone using the Jericho 2 Broadcom chipset on their MPLS backbone as well as the provider edge. This is quite similar architecture design as the one in the South Asian customer that we showed in the previous slide, using the different type of Jericho family chipset, but the architecture is pretty much the same. And again, we want to showcase all these examples that this is not just a design in a textbook case, but they are actually being implemented in production. And last but not the least, we are implementing on the data center line of business as well. The last three examples we are showcasing are more telco focused. And this one is actually with a customer in Japan running in production using some of our Crumon 2C Broadcom chipset, building their spine and leaf to support their computer storage and their compute server farm as well. So this is another example that is actually in production. Now, I want to highlight a little bit about this architecture using the Crumon 2C family, both at the spine as well as on the leaf. As some of you might already know, spine leaf is a extremely scalable architecture, allow you to scale horizontally as your server farm, as your compute device are growing. And that actually become a lot more important as the AI farm are growing in the industry. In a second, I'm going to show you another example, but I like to build my story on top of that. Looking at a traditional server farm, compute storage type of design using a spine and leaf that allow you to scale horizontally using the Jericho or the Crumon 2C architecture. These other example, we are partnering with another customer on the AI cluster. Architecturally is a spine leaf design, but as you can tell, this is actually another tier running with the AI farm on the connecting to all the leaf with dual home connection. So for those of you, if you are interested to understand a little bit more about like how the AI traffic works, every AI farm, or we call it the AI pod, like showing in this picture, the part 1, part 2, and all that, all the AI computation, which basically the CPU plus the GPU doing all the data computation, some of this traffic on the GPU are actually crossed from each of the pod, meaning some of the pod are doing one portion of the modeling or the computation, and the other part are actually doing another portion of the modeling. And there are traffic across these different parts to come up with the AI model. So not only the traffic on south and north, but they actually are east and west. So I want to highlight that traffic flow architecture in the AI world, because these actually makes the scalability a lot more flexible. Either regardless the traffic need to go south and north versus east and west. With the AI farm computation, with the data modeling, east and west traffic actually become a lot more important than the traditional data center. So showcasing here, we had the XGS, the Broadcom, the Tomahawk 5, the latest 5 nanometer chip, along with other latest Jericho 3 family. They are both the latest chipset 5 nanometer design to support high density 400 gig and 800 gig connection. So all in all, these provide a total solution of what nowadays a lot of companies are looking into building the AI cluster infrastructure. So showcasing this with our powerful 800 gig switch on the top, and also the AI farm with the GPU on the bottom. And again, I like to highlight these are serving the traffic south and north, as well as the west and the east, which is very important for the AI traffic pattern. So far, just to recap, we share a couple architecture. We share a particular customer testimony, and then with about 3 or 4 showcase from the access to the core to the data center, and then last but not the least, with the AI cluster that we are doing a proof of concept. So those are the things that we like to bring to the table. I hope this is a good sharing with the audience. Any question, feel free to reach out to us from our marketing team, and we're happy to address any further question. Thank you. We'll turn this back to the host.